Good morning, everybody, and welcome to today's webinar on fabric solar technology presented by IFAI's Advanced Textile Division. My name is Jonathan Curry. I am the Division Supervisor for the ATP Division of IFAI. ATP represents safety, medical, and interactive textile products marketplaces and works to grow its members within the industry. ATP is one of the fastest growing divisions of this association. The division also provides a forum to exchange information, solve common problems, and develop mutually beneficial relationships. Before I get started, I'd like to go over a few items so that you know how to participate in today's event. If you are not already, please ensure that you are muted so no additional background noise is heard during the presentation. You will also have the opportunity to submit text questions today to our presenters by typing your questions in the question pane of the control panel. You may send in your questions at any time during the presentation. The presenter will collect these and address them during the Q&A session at the end of today's presentation. In addition, please use the attendee pane to participate in our Markets Served poll. This will help our presenters. I'm now happy to present Colin Toohey of Pvillion. Colin is the CEO and co-founder. He is an electrical engineer and a business leader who has worked in solar, wind, hydropower turbines. He has been the recipient of grant funding from NASA for alternative energy resource and was recently named to Forbes 30 Under 30 list for 2017. Welcome, Colin.
Thanks everyone. I want to introduce my company and what we're doing here today, and thank you for the kind introduction. Fundamentally what we do is we integrate solar cells and fabrics, and those solar cells can range for applications from consumer products and small products all the way to large architectural products, which could be industrial or architectural or commercial. I want to get a little bit into our background, although this is not working. Hold on one sec. Oh, never mind. Sorry, one sec. So what I'm going to talk about is a little bit about our history, the history of solar fabric and how it's evolved from a technological standpoint and from a market standpoint, and then get into three main categories. One is architectural applications. Then that is sort of more on the construction industry, grid-tied, large-scale applications of fabric integrated solar, and then the temporary applications, which might be portable products. Those portable products could be umbrellas, canopies, awnings, temporary tents, shade structures, and then get into the consumer products goods side, which is more of what we're talking about on the small mobile charging, remote location applications. I also want to emphasize that there is a poll, and I'm going to talk about those three markets and those three different technology opportunities. However, if people can answer what they're most interested in, if we have a disproportionate number of folks who have particular interest in one market or in one technology, I'd love to discuss that in more detail. Not that we're going to drop any of the other topics, but I think that's important to realize. I just want to talk a little bit about our history and where we come from. My partners in Pvillion are Todd Dallin and Robert Lerner, both from the FTL business. So our background is in lightweight structure engineering and tensile structure design. So that's kind of our DNA and where we come from, founding FTL in the 1970s. Which evolved into a lot of technology development through the 80s and 90s. And as part of that technology development, we got into integrating solar cells with fabrics with the express and initial purpose of building portable tents that produce electricity. That evolved with the U.S. Army in developing military products. So those military products, so those still in use, have evolved to architectural and temporary applications. So most of our business is currently in commercial applications, though we are involved with the military currently as well. So I want to talk a little bit about the technology as evolution and sort of where we've come from. A lot of folks think about solar and flexible solar as thin film. It's this sort of early promised lightweight, low-cost, roll-to-roll processing. Just a sort of spoiler alert, thin film did not pan out to be what people thought it was. So we've been working with thin film for decades, but really what it is it's a product that can be manufactured a lot like on a printing press, where it's a roll-to-roll process where you could build a product or a product line that is miles long, and it's theoretically really cheap to manufacture. However, these promises really didn't pan out. There are tremendously high-quality thin film products out there, but the efficiency is low and the cost is high. So what we have really evolved from the thin film industry, although we still work with a number of different thin film materials. We think that there's promise, but it's not really the promise that was anticipated 20 year ago. So what we've done is we've really evolved moving into more traditional materials, and that is using different crystalline and monocrystalline cells integrated into non-traditional materials. But what I am doing is just showing some thin film applications early on of integration of thin film. And the promise is there, which is lightweight, flexible, easy to install. And that still is our goal with our products, although we're not using as many thin film devices. So what we've really done is we've evolved in terms of the technology that we've been using. I would say most of what we're doing is with monocrystalline material. It's low cost in comparison to a thin film or a super high efficiency flexible cell. It's more traditional. It's what you'd see in any glass mounted array. So what we're doing is we're taking more traditional solar cells, which are proven, cost-effective, lightweight, easily accessible, and we're laminating them into fabrics and into alternative building materials. Now, these have been proven over the years, and that's a big reason why we've evolved to work with a lot of monocrystalline. You can see in the middle here 2 different types of thin film technologies, which have promise and have had promise. But there are some significant cons, mostly that they're expensive and they're lower efficiency. So what we lose with a certain amount of flexibility on the monocrystalline, we gain with efficiency and price. Now on the right side, you see a much higher efficiency, much higher cost solution, which might really be for military and high-end commercial applications, drones, UAVs, remote locations, soldier systems. And those are great products, though approximately 100 times the cost of anything else on the market. So what we're really doing is we're saying we can take these cells and we can laminate them into large-scale architectural applications for industrial use and for commercial use. And that means that these are grid-tied. That means that they're coming from a place of architectural code. That means they meet NFPA. That means they meet all the UL standards. So what we're doing is we're structurally engineering products, and we're also electrically engineering products to develop systems that are holistically integrated. I'm going to go backwards a little bit and just get into the types of structures that we've done in the past, not on the technology side, but on the development and engineering side. And then, as you can imagine, any of these types of structures, which we've been developing for decades, can now be solar powered. And that is for new structures, that is for retrofits, that's for building facades and temporary structures. just going to flip through a few different projects. And on the architectural side, one thing we've really been working on, and we feel is a real heavy application, is the facade development. This is a project we worked on with Kieran Timberlake, which is a U.S. embassy in London, doing the mock-ups and development engineering for lightweight solar integrated into facades. So now this is a non-traditional application of solar. So rather than integrating the solar cells into a flat glass laminate with aluminum frame, we're saying we can integrate these cells into perforated aluminum panels, fabric, ETFE, structural membranes, and we can build passive shading elements as part of the architectural design. So what we do is we work early on with architects to develop these systems, and then our responsibility is to provide the materials, provide all the testing, structural engineering certification, electrical engineering certification, and then all of the design, build, install requirements for the project. Now, while some of the applications are permanent, even if they are permanent, you need to think about things like warranty and replacement. So there is minimal maintenance, and when there's maintenance done, you have to think about how you actually would maintain these systems. So we've developed a couple ways of creating double skin roofing membranes, which might be for an industrial application, it might be for a large-scale tensile structure, stadium roof, amphitheater. And what that is really looking at how you can install and remove these systems without replacing the entire membrane. So that's for a retrofit or for new construction. And what we've done is we've developed a system that can take a fully finished solar membrane with all of the electronics, all of the wiring, all the solar cells laminated in, pack that up in a truck and bring it to site ready to plug and play install on an existing or a new membrane structure. And so on the left you see an example of how a physically independent piece can be installed onto an existing membrane roof but still fit the contours and meet all the electrical and code requirements of the system. So we're involved heavily in the early engineering stages of the membrane itself, whether we're doing the engineering on the membrane or installation on the membrane or it's a third party. That really depends on the project. Here we just did the solar membrane portion of it. Whereas we can do freestanding membrane structures, which are shade canopies that you can see in this project, which is the Cascades Connector Bridge. We worked with FIG Bridge engineers. They were the designers of this beautiful bridge. And really what we're doing is we're providing shade, shelter, and electricity. So there's full drainage on these systems. There's guttering on the fabric. And really what we're doing is we're creating a new medium onto which solar can be applied. So this is not a particularly large project, but you can see fully grid-tied engineered structural system that where we provide reaction loads into the bridge and to the bridge engineers where they're able to work together and to coordinate with us. I want to pause for a sec and just ask if anyone has any particular questions. Feel free to type them in. That's how we're doing this with this webinar. So feel free to ask any questions. Another application as we transition from the permanent to the temporary are carports. Carports are a very large market in the U.S. Solar-powered carports. Our solar carport is about half the weight and uses 30% less steel than a typical PV carport. So in scale, for installation, it's quicker, it's easier to put up, it's easier to take down, it's lighter, you get more watts per volume of material, more watts per kilogram of material. So really what we're trying to do with these lightweight structures is span larger distances and produce more electricity. This is a project that we did as a pilot run for Google's headquarters in California. It's a 4-car carport which is tied directly into the grid, but also provides shade and shelter and electric vehicle charging for this particular application. And you can look at permanent applications in two different ways. You can grid tie them, so even if you have permanent foundations, you might want to grid tie it, and you might want to sell it back to your utility, or you might want to have a permanent battery system, which is taking the entire system and looking at how to store the energy and use it later. Now, on the right, you see more temporary applications. So this is taking the same system, taking the same concept, and saying we can do traveling road shows, marketing events, event tents, canopies, temporary applications, and this we all developed for the military. So the systems were developed for the military, but now we're moving them into the commercial markets. And I'm just going to touch on a little bit of the military market. That it's not as market specific, but it's really technology specific, which is saying these same ideas can significantly be applied in a lightweight, flexible setting where something can be temporary, taken up, put down. We've developed a lot of different military applications over the years. But as you see on the right, you can see an event tent which is powering a concert. We have not rolled these out in large scale. For development reasons, but I think we're at a point where we really have proven out this concept with a number of pilot projects which we've tested over the years, and so we're really launching and sort of scaling up our production of these high efficiency solar cells, looking at monocrystalline and fabrics. Let's see. Sorry, trying to change the setting here. Okay, so another thing that I want to introduce, and this is not particularly relevant to the fabric specifically, but we treat metals like fabrics. So we create doubly curved membrane structures out of flexible metal. So it could be a stainless steel, it could be a perforated aluminum, it could be a number of different composite materials. But really what we're doing is we're taking solar cells, laminating them onto a substrate. Half of the time it's fabric. Actually more than half the time it's fabric, but sometimes it's aluminum or a steel. And this is just an example of a trellis structure and a carport structure that are using the same concept of lightweight, large span structures, but integrating them with solar cells. I have a question here which is related to the type of flexibility. What type of flexibility can you expect in high wind areas like the desert of California? Well, what we do is we really look at local building codes. So the high wind areas, we're engineering for whatever the building code is, and whether that's a permanent building code or we are looking at the payback for temporary applications, we're open to whatever the engineering requirements are. Generally speaking, it's the steel structure that's going to be affected by the wind loads and the snow loads. It's not as much the fabric membrane and the construction of the fabric membrane, because these systems are highly engineered, super strong, super heavy duty. In terms of flexibility, I'm not sure whether you mean literal physical flexibility, but I can touch on that, which is when we're looking at the different flexibilities, and we can get this into this with some of the consumer products, what we're really trying to do is make a flexible membrane, but on an architectural setting, it doesn't have to be that flexible. So if you look at this not the upper left, but in the middle on the upper side, the factory with the layout of the PV modules onto fabric. These are folded up and packed in a reasonable way where the cells are not folded. The radii and the curvature that you're talking about with a lightweight fabric structure is not tremendous. So we don't really need to achieve super small diameter radii and a super small diameter curvature. So For us, the monocrystalline cells with slight curvature are enough for an architectural or commercial application. There's really no need to go into tremendous flexibility. If you're talking about a roller shade, if you're talking about something that does need to roll up, like you can see on the left, that's a thin film application, that's totally doable. And those flexibilities can get as small as a 3-inch radius or as large on an architectural setting as a, let's say, 24-inch radius or a 12-inch radius for something that's going to roll up in large scale. And so what we do is a lot of our own in-house manufacturing. We work with some third-party contract manufacturers, but we do all of our own in-house testing, in-house laminating, in-house electrical testing, structural testing, and you can see that with some of the development here. We're really we're not an R&D lab per se. We're real product developers, but part of the complications are, how do these materials elongate? How do they last for 25 years? Because that's really our goal, is a 25-year, 80% power production warranty. That's really the goal for us, is to look at these systems and do aging testing and accelerated weather testing for different material properties and different fabrics. And then not only the adhesion, not only the lamination, but the electrical characteristics and how those might change over time. Someone asked about safety, UL. The requirements for UL are 1703, and that is not necessarily for every AHJ in the country. But UL 1703 is kind of the gold standard in this country, and that's what we shoot for. And that involves that 20-year or 25-year, 80% or 90% power production. So there is some degradation over time, but for UL standards, there's a certain warranty requirement. The compliance with model building and fire codes, our systems and our fabrics, we ensure meet all the NFPA requirements. Certain applications don't require that, and certain jurisdictions don't require that in the same way. Some for temporary structures, some for permanent structures. It's all different, but I can assure you that we comply to whatever the local codes are with what we're building. I want to get into a little bit more of the architectural facade conversation. I talked about passive shading, but really what we're doing with a lot of architecture firms is looking at how we can sort of kill 2 or 3 birds with one stone, and that's really the fundamental of what the purpose of what this technology is, which is provide shading, provide shelter, and produce electricity. And so here you can see this system, which is a building wrapper, which the system is designed as a passive shading element. So to reduce cooling loads in the building, there's a passive shading element, which is a translucent PV membrane, and that translucent PV membrane is shading the building, helping the cooling loads, but then also producing electricity. This is a net energy positive building, and that's the goal of this program. There's no way that could be done by just putting PVs on the roof or just putting PVs on the facade. So it's a very different, aesthetic and a different look, but we're really looking at it as a building material and a building tool for architects and contractors to work. Looking at some of these questions. Some are asking, how small do the individual cells go? The cells can really go as small as you want, depending on the scale. That being said, we really work with a framework of a 5-inch by 5-inch cell or a 4-inch by 4-inch cell. And so what that is really looking at a building block as a pixel architecturally. So you have this 6-inch by 6-inch cell, and the question is, how do you paint with it? How do you use it as a building material or a building block? So what we're doing with those cells is we are developing lamination systems and wiring systems for all those cells to work together into a particular membrane. So while a solar panel's goal is to have a positive and negative coming off of one panel, we have a positive and negative, or an AC coming off of an entire fabric system. So that might be a permanent application, that might be a temporary application. But the cells themselves can get much smaller. It just depends on the scale. We're working with some temporary umbrella structures, and this is basically providing solar shading. So this is for shade, shelter, and electricity generation, and this is for off-grid applications where you want USB charging, some LED lighting, some laptops to charge, and the goal is really to say, how do you produce electricity in a remote location without running conduit to that area, and provide a sort of pre-packaged system where there are solar cells built into the membrane structure. So let's see, we're going a little bit beyond the temporary application, but the ultimate temporary application is looking at consumer electronics. And we're looking at these wearable products, and that doesn't necessarily mean it has a Bluetooth sensor and a heart rate monitor. Really what we're trying to do is provide low-hanging fruit, which is charging devices that you already have. And that means the integration of these products into different garments, into bags, into backpacks, and the market for these types of products is tremendous, and the integration of the solar cells and the fabrics has evolved over time. 2-3 years ago, we worked with Tommy Hilfiger on launching a solar-powered jacket. That was a pretty big success from a market standpoint, and now we're working with a number of different partners to launch similar products. So I can tell you that what we launched with them was pretty clunky and heavy and more of a proof of concept, and now we're in a much more flexible, much more reliable, less clunky standpoint. And so what that means, if you see on the right, is we're really looking at super flexible materials integrated into a lot of these garments, and those flexible materials are a lot different than what we do on an architectural setting. You can see we're doing tote bags and backpacks and clothing, and there's a really, really big market for this. So we're acting as a supplier for some of these materials in garments, portable chargers, portable charging. And we're offering our services and our materials to third-party brands. We're not launching our own products, but we're working with a number of brands to launch new products. And so, you know, as we kind of come to a little bit of a close, these are some of the applications where you're really talking about getting the electronics into the fibers, and that really is the future. We're talking. The current state of the art is mostly laminate based, and the next step, which we're developing, and we have partners with which we're developing systems that are actually sewn in to the yarns and laminated into the yarns of the fibers, and that really is our next step. That's not here today, but that's a couple years out, and we're really saying, well, rather than having a heavy laminate, how do we make this more flexible and lighter weight? And that's on the consumer product side, and we're seeing a ton of demand on the consumer product side. On the architectural side, I think it's just important to look at a lot of different systems that are taking advantage of doubly curved surfaces and complex features with parametric modeling. So, you know, the idea of taking a rectangular building and putting solar panels on the roof is pretty straightforward. What we're doing is very different, which is saying, how do we take complex curvature, complex surfaces, whose intention is really interesting curvature, interesting form, and integrating our solar cells into those materials. So that's really our next frontier, is to look at very large scale, complex curvature, and large scale applications for architectural use. And then sort of scale that down into the commercial use as well. So I will leave it at that at this point. For any particular questions, there are a couple questions that we're looking at on the list of questions. I can answer some of these right now. Someone asked, what about the washability of these garments? The products themselves are waterproof. We really put the electronics into the laminates, and those laminates are not only waterproof, but have a very solid water vapor transmission barrier as well. So they're very solid in terms of washability. Where you're not going to get as good washability is in protecting whatever battery or PCB or USB you have built into the garments. So that's actually a system that we're working on now for some temporary applications, and we can sort of talk about some of that offline. Let's see some other questions. The passive shading structures. Is that enough? The lifespan. Again, we're talking about a 25-year power production warranty, and so that's really what we have to meet in order to match the industry standard in this application. And sometimes the fabrics themselves are not warranted as long as the solar cells, and so what we deal with is a particular distinction between the warranty on the fabric and the warranty on the cells themselves, and that's part of the reason why we make some of our systems removable. So if the fabric wears, you might be able to actually keep the cells and replace the fabric, and if the cells go bad, you could actually replace the cells and keep the fabric. So that's a lot of what we're doing. Let's see, any other particular questions? Maybe we can ask with audio. I'm not sure, John, are there audio questions that people might have? Or if you want to sort of start the conversation.
We haven't done any audio questions on these types of webinars before, but I think there's a hand-raising function that audience members could use. If not, I'd recommend putting more questions into the question and answer section. One question I would have for you, Colin, is, how do you feel that, collaborating with groups like the Advanced Textile Division of IFAI works for a company like yours?
Well, I can tell you, I mean, we're a small business, so we're always looking for partners with which we love to develop different products for different markets. So, I mean, I think we can be a resource for any questions that folks might have. We're also very open to co-developing products, right? I mean, we don't have the intention of developing an end-use product for every single market and every single application that you can think of. But I can assure you that we've thought of all those ideas. So if there are folks who are building a lot of shade canopies or are building a lot of awnings, for instance, and are market leaders, but are lacking the sort of technical development on the electrical side, solar side, lamination side, we'd be very open to working with folks for distribution, but a lot of it for R&D and product development. So if there are particular market opportunities that we're missing and folks who have real excitement with a particular project, whether it's one client or particular sort of long-term relationship, we're open to that. So, that network and the IFAI network has been super helpful for our development in specific markets.
That's great. And as a division, if there's any attendees that are interested in connecting with Colin, they can feel free to contact Janelle Wells or myself, and we can help make those connections. I am seeing a couple questions here in regards to getting copies of the presentation and or the recording. We will be able to provide those to you after the webinar. Information will go out so that you can get access to the recording if you were late and or a copy of Colin's presentation.
Yeah, so I see a question, are you using specific fabric? It looks like PVC fabrics are what you mainly use. It really depends on the application. We can talk offline, but I can tell you that we have a lot of different fabrics that we work with, and some are industry specific and some are project specific. So if we're talking about a heavier duty permanent architectural application, the warranty requirement is going to dictate which fabric we're using. Every fabric has a different lamination requirement, so we test all of that, and we have developed systems for certain laminations to different fabrics. Some require certain treatments, some require certain modifications and customizations. But if there are fabrics that someone wants to work with in particular that we don't work with already, we're open to that as well. And we do a lot of our in-house R&D on the lamination side and how we would work with those specific fabrics. So there's no one answer to that question, unfortunately. On the consumer product side, we're really talking mostly about synthetic fabrics and generally speaking, fabrics that don't have a lot of stretch. Laminates can get a little messy with some stretch. So we're talking mostly outerwear. We're not talking about T-shirts yet. That's a couple years out. Polyester, nylons, different coated fabrics and synthetic fabrics. So we're open to working with a lot of different fabrics, but generally speaking, I think the less stretch, the better at this point. Someone asked about, do you match up your solar panels with the knit HDPE fabric for smaller shade sails and shade structures? We have, and that is actually something we're very interested in doing in the near future, is developing that a little bit further, because we understand that market is pretty large, and we also understand that the cost is lower, and that's something we're trying to get into. So we would be open to doing more of that. Let's see, someone asked about DC optimizers versus string inverters. I would say it's DC optimizers versus microinverters versus string inverters. So just a little bit of background for those of you who aren't as familiar with solar. Solar energy is a DC current, and so what you need to do in order to tie it into the utility grid is you need to invert it to AC, and you can do that a number of ways. We like using DC optimizers or microinverters. What that means is you are locally monitoring and inverting that DC to AC, or at least with the DC optimizer, what you're doing is you're maximizing a certain amount or a certain area of the membrane. So what we're looking at are membrane structures that might have curvature, meaning that certain cells are facing a little bit farther east and certain cells are facing a little bit farther west. If you wire all of those things in one string directly, you may lose a lot of your efficiency. So what we do is we locally invert, or we locally optimize particular areas. So you might say a 5-foot by 5-foot area has one inverter specifically oriented to that direction towards the sun. What that does is that optimizes your amount of energy throughout the course of a day and throughout the course of a year. But what it also does is it allows us to individually monitor areas on the membrane structure. So we can see remotely that, oh, the upper left area of canopy 6 is not working as well. Why is that? And that really helps us from our modeling standpoint and from our maintenance standpoint. Let's see, do we provide samples of our solar fabric? Yes, we can provide some samples. It depends on the application. Get in touch with us offline. You should have our contact info from Janelle and John. That would be super great. I'm not sure whether you're talking about on the consumer product side or on the architectural side, but we have dozens of different materials that we work with, so we'd have to get a little more specific on that question. Let's see, on the smaller scale product standpoint, how did the process for product development go? I think that's a really great question, because sometimes the technology is the easiest part, and that's what we find often is the case when we're building relationships. So the way we work often on the consumer product side is that at the end of the day, what we're providing is a wired finished piece of a garment or piece of a bag, which is then sent to a particular manufacturer or a particular brand for them to sew it or laminate it into their finished garment. So we provide cut pieces with wiring, electronics, PCBs, USB, battery, and solar cells all as a kit, and we might send that 10,000 of those pieces to a particular bag factory that's run by a brand, and they would manage that process of integrating the two. We work very closely on that supply chain together, so that all the warranties and they're doing everything up to our standards, and we're doing everything up to their standards. But in terms of the early part of the process, what we do is we generally act as a sort of design assistant, and we work collaboratively as a team. So someone might come to us and have a sketch or design concept, and we work them through their tech pack to make it realistic, to make the dimensions reasonable, the wiring reasonable. So we act as a collaborator very early on, and then we become a supplier by the end of the project. So that's generally the transition, and we work with both the design team and the production and supply chain team. So we really follow that process from very, very early on, design, sketches, blue sky concepts, all the way to production, customs shipping, logistics, and that's how we follow that flow. So we'd be happy to collaborate with a brand or a fabric company who's interested in something like that. So let's see. Someone asked, how can the products be integrated into shading structures? I think that's a similar process. So we would work early on with your concepts. You come to us with a concept, and we would take that concept and turn it into reality through the design, engineering, manufacturing, and installation process. Generally speaking, it's a collaborative process. We're not working in a vacuum. We're working as a team. So we would figure out what the best way to work in a team for a particular way, the particular setting or particular project. Let's see. How is the cost of the system compared to fixed or solid PV panels? It's going to be more expensive. You know, it's not going to be many multiples more expensive, but it is going to be more expensive, and that's really because you're adding value in two ways. So would we take our fabric and just throw it on someone's rooftop and compete on price? No, because what you're doing with the fabric application is fundamentally adding value in two different ways, which is the shade canopy, it is the structure, and it's the solar. You know, so it's not really about just the energy production. So how does the cost compare to a non-solar shade canopy is really more of the question, and that is not multiples. That's a marginal increase in cost. And we can talk pricing and specifics offline if anyone has any particular questions. So let's see, John, any other thoughts, questions that I'm missing, or anything you think I should get into?
No, I think we've covered everything. I just want to reiterate that you know, if folks do have questions later, they can either funnel those through us and we can reach out to Colin, or they can reach out to you directly.
Yeah, that's great. And if anyone has specific questions, we'd be open to that. But also just broader sort of relationships. We're based in New York. We're happy to meet with folks, get on the phone, see what people do. And we're really about creating partnerships. So if there's a project that someone has in mind, we'd love to co-develop something or to come up with something together.
Well, I think that's great. And you know, from an ATP division standpoint, I think today's webinar was an excellent opportunity to collaborate with your company as members. Other members on the line, I'd encourage you to reach out to Janelle Wells or myself if you have a member-led webinar proposal, and we can look at providing the same opportunity that we provided Colin today.
Great, thank you. And again, feel free to get in touch with us. We're happy to answer questions.